the next example, number 3, we supposed to try to prove to you that the integral of the function sine g omega naught t times cos k omega naught t supposed to be equal to 0. We're supposed to prove that because this is the equation that I stated to you earlier. So the way to prove equation 15 turn out to be equal to 0 is we let c to be defined as that integral that we want to evaluate. So let's try to evaluate the value of c, and hopefully it will turn out to be 0. Okay? C is defined as the integral of sine g omega naught t times cos k omega naught t. Well, from high school trigonometric relationship again, we know sine of the summation of the two angles is given according to equation 16. So for that reason, we can see that if we take sine of the summation of the angle and then we subtract the next term, which is sine of k omega naught t cos g omega t, then the difference between the two, which is the whole thing in here, is the same thing as sine of g omega naught t times cosine of k omega naught t. And that we're supposed to take the integral. As a matter of fact, you can see basically equation 17, it just says that the value of c that we would like to evaluate supposed to be the integral of sine g omega naught t cos k omega naught t. But using equation 16, we can express sine of g omega naught t times cos k omega naught t as shown in equation 17. Okay, so right now we do have equation 17. Now, according to equation 17, the first integral that we have is the integral of sine. The integral of sine. Well, according to example number 1 or example number 2 that we just derived, the integral of sine, we know it is equal to 0. So, according to equation 17, all we have left is c is equal to the integral of minus sine k omega naught t times cos g omega naught t. Okay? However, as you can see from the next slide, which is equation 18, as I told you earlier, the first integral right here, the integral of sine is equal to 0 based on example number 1 or example number 2 that we just computed. And so all you have left is the value of c is equal to the second term, which is shown in equation 19. Now, according to the previous slides, we also know that the definition of c, we define as the integral of sine g omega naught t cos k omega naught t dt between 0 to the period t. That was the definition of c. So now, if I add both equations, left-hand side with the left-hand side and the right-hand side with the right-hand side, let's see what do we get. Here we have c plus another c in here. That is equal to 2c. And then if you add this right-hand side here that we defined earlier, that integral, if we add that with another integral in here, including the minus sign, then together what we got is the right-hand side right here. This is what we got when we add the two right-hand side together. Okay, so based on that equation, let's see if we can simplify a little bit. What we have here is this. Sine of g omega naught t cos k omega naught t minus sine of k omega naught t cos g omega naught t is the same thing as sine of the summation of the two angles based on the high school formula that I just told you about 1 or 2 slides ago. So the function inside the integral from 0 to t, which is this term combining with this term right here, that is exactly equal to this term, okay? And then we can simplify a little bit more because you have omega naught t here, you also have omega naught t in there, so you can factorize that term in here. So what you have is equation 20, which is stated like the integral from 0 to t of sine of g minus k times omega t dt. That is shown in equation 20. However, according to example 1 or example 2, we already proved earlier that the integral of sine of a function is equal to 0. So this guy is equal to 0. So in other words, we already proved to you that 2c is equal to 0, and therefore c is equal to 0. But don't forget again, c is defined like this, and we just proved to you that c equal to 0. So in other words, we already proved to you that the integral of sine g omega naught t times cos k omega naught t between 0 to t is equal to 0. We just proved it to you through this example. And basically, that's what I just said on the previous slide. 2c equal to 0, like I told you on the previous slides, and therefore c is equal to 0. But we all remember the definition of c is here. So we already proved to you that this integral is equal to 0. This is one of the relationships that I stated to you earlier. And that's the end of this lecture. Oh, wait. Acknowledgement.